To say, for documentation purposes, but we were not live on YouTube yet. However, we are live on YouTube now. So, for actual documentation purposes, what we are working on today is basically me kind of giving up on the custom scripting language thing. Due to other circumstances, I'm going to have less time to work on this, meaning I need to work more efficiently. And I figured out, the runtime that I made for loading and running my scripting language, with a few minor modifications, but like almost none, could, in its current state, load, it could load Rust stuff. So, well, I mean, that's what this does, so, yeah. No. So if we run this now, and this code isn't going to get run, this is the actual main function. So if we just give it this bytecode file, so JIT create BC, we actually do load, so this is LLVM bytecode, through the Rust C, the Rust compiler or whatever. You can actually tell it to output LLVM bytecode or even LLVM IR. So that's the text representation of what this is, but we actually want the bytecode version because that one's smaller. Anyway, so we just run this on Rust code, that gets compiled to this, which is LLVM bytecode. I then copy it over into our build directory because, the program needs to be able to find it. I mean, it could, but I'd have to type out a long path. Anyway, once we load that into the runtime, I'm not actually JITting anything yet. However, it's all loaded in. So, on this command line, the first thing you see, why isn't this playing more? Oh, did I just accidentally bump my, I didn't. Where's my audio? Oh, there it is, it was just paused. Anyway, so we have LLVM intermediate representation here. I have to look into seeing if this is the anyway, stuff for later. We have all of the LLVM intermediate representation here, and I'm just printing that out for debug purposes to see, hey, are we actually getting the LLVM intermediate representation? And I can also look at what data is there that we can extract. And then this is what I've really been working on. I've been working on writing a demangler for Rust symbols, because to actually JIT the correct function that we want to run from Rust, we have to be able to ask for the function from Rust, meaning we need to be able to speak its language. So the first step is decoding it and then writing it ourselves. So I've gotten most of the way to the decoding stage, so you can see I was able to demangle the symbol to JIT crate, test, mod, add, and ignore those. The spec says we're not supposed to print those out, but I'm doing it anyway. Because they're actually part of the symbol, so I will have to encode these later, so it's like debugging info, even though an actual demangler should never show those. What was I gonna show? Right. So if we look at our the Rust code that we're currently compiling and then analyzing, you can see we have two public functions, add and subtract. These both take 2 arguments and they return 1 argument. And then I have something that it's two functions that do the exact same thing, but with a structure. And this is just so I can practice, you know, different stuff. Different symbol demanglings. Because the main things that we're going to be JITting are just grabbing the definition for structs, so they can be used as components in the entity component system. And then grabbing functions, and then I'm not sure about member functions. We might grab member functions later. Then again, these aren't... Do you call them member functions in Rust? Anyway, implementation functions. So we have this implementation section, public add, and public subtract. And down here you can see that we do in fact unjit them as well. Not unjit, demangle the symbols. So you can see we find add, JIT create, test mod add, JIT create, test mod subtract, JIT create, test mod, and test mod is the module. Args, so it's printing out that implementation right there. Actually, I think I'm printing out the type the implementation points to. So there's two values here. There's the type that's being implemented, and then the actual path to the implementation. I'm not quite sure how to deal with that yet, or just how that works. But I can dejit it because they give you the grammar for that in the documentation. But yeah, so our next step is figuring out how to do this in reverse. How do we write this from something like this? And that I do not know. I think what we should focus on first is just grabbing non-implementation functions, because for now that's all we would need from a scripting system. So that's what we'll do. And I am going to... So we have like a pretty print version of this. Let's make a more debug version of this. That's like fully breaking apart that, so we can understand it a little bit better. And the print functions are in here. And the main thing we want to print is do we have namespaces? And all I'm going to do is this, so we can figure out which namespaces are part of, or which paths are which part of which. Where is... Oh, trait diff, implementation path, inherent implementation path. So this is the main one we care about for now. Let's see, what members did we have here? Yes, the implementation and the type. So we're going to print out the implementation path, and then we'll print it out like it's a template, basically. So those are the two main things, just making sure we know when a path has a path, like we scope paths. And then we print it out again. And this is a lot more useful. Because we can see we have a value path. Inside of the type namespace, JIT create test module. Because functions are in the value namespace. And you're not supposed to print these out. They're like internal namespaces. They don't say what they are. But it's obviously value and type. Because you can see here, the test module is a type. Value. Alright, this is the implementation path. Value add, which is an implementation in this one. Oh! Okay, that makes sense. So this is the path to the implementation. So if we implement a path in a different module, so if we were to do something like mod test mod 2 or something like that, and we put the implementation for the args struct. No, I want to paste. There we go. Implementation of args. Use of undeclared crate or... No, it's not that. What is the Rust way to... Oh, it's using, isn't it? Use... Is that right? Cannot find type args. Test module. Args. Okay, yeah. So if we did something like this, actually, let's just test it. But first, my theory about what's going to happen. This path right here, that's going to become test mod 2. And this is going to continue to be test mod. So, go to, we run this. Did it run or did it not run? Okay, yeah. It didn't complain. I don't trust it though. Okay, it is working. So let's paste that in there. Let's run our testing program. Okay, yeah, my prediction was correct. So this is where the implementation exists. And this is where the type exists. All right. Let's try JITting a function. First, I'm gonna see if there's an implementation of these. So it calls it. It also declares it. Okay, so those are magic functions. Oh, we will just see what shows up. I'm fully expecting us to have some missing compiler links that we will have to provide eventually. Okay. So we're gonna do two things. First, we need to be able to convert from these nodes, from this AST, back into a mangled function, a mangled symbol. Then we need a user-friendly way to create that symbol AST. so we do use this. Or do we? We don't ever set that. Am I forgetting to... Okay, no. We just match path. Oh. We want to set crate there. And since crate is just a path, I think we should just enforce that this is a crate path and then delete the crate node. So this is what we want to keep. Delete rust crate. Oh, I want symbol name. That's what I wanted. And then here. No, I wanted the other one. I wanted that one. There we go. We want this. Otherwise, we want to return error. Yeah, we want to just return that it didn't work. And I just realized we weren't printing out the crate at all. Well, we are printing out the crate. Right. Oh. Wait, shouldn't this have a disambiguator? Oh, the identifier is a disambiguator. Oh, it's an int. Right. So we'll just print out the disambiguator. Disambiguated. The disambiguator, I feel like that should be unsigned. Oh well, it works. Let's see, great. And the S is the disambiguator symbol. And then that is the bytecode. I think it's base 62. Yeah, base 62. Actually, how is this thing negative? That shouldn't be possible. Hello, how's it going? I might be decoding the base 62 wrong. Let's drop a big, cannot speak. Drop a breakpoint there. All right, matching disambiguator, perfect. This is the one we want. So I am currently attempting to load Rust code at runtime in I am explaining this terribly wrong. I'm trying to use Rust as a scripting language. And to do that, we are first compiling Rust to LLVM bytecode. So it's like cross-platform, pretty easy to work with. And then our runtime the plan is to use LLVM JIT stuff to then load that bitcode and JIT compile the Rust, and then just call functions like a scripting system. Right now, the part that we're on is we can load the bytecode. So like here you can see all the bitcode kind of just printed out. And then here what we're doing, what I paused before we're printing out, is we need to be able to generate the mangled symbol for the function we want to look up if we want to look up a function. So essentially, we need to generate this weird bit of text right here, and I just realized I forgot to resize the editor. Let's bump that up to 25. That should be a lot easier to see. There we go. Nice. Okay. Turning this, well, turning something human readable or just an API calls into something that is actually usable. So you want to make a language. I would say definitely look into the LLVM documentation. I know I think there's decent Rust bindings for it. In fact, the reason I'm working on this in C++, even though we're loading Rust code, is because I didn't want to have to deal with rewriting my existing LLVM code from a different project I'm working on. But I'm sure it's perfectly usable. But yeah, look into LLVM. They have like a good toy language examples and all that good stuff. The examples are in C++ though, so you will have to translate it into Rust, which shouldn't be too hard, unless the API is like super different. Let's see, what was I doing? Right. We were debugging here. Why is this producing a negative value? The value is 0. That checks out. I bet we're just running into an integer overflow here. Yep, integer overflow. So nothing wrong with my code, just wrong data type. Let's turn this into a uint 32 type. And then final uses of this. Okay, we want lifetimes to be uint 32s now. We also want the disambiguator itself to be an unsigned 32-bit integer. Now if we run this again, okay, thinking about it, there might be a better way to go about this. So instead of making it to where you ask for a specific function, instead what we do is we just extract everything in there and organize references to it. So instead of having to reverse engineer this completely, we just reverse engineer it enough to be able to get out the important bits. Like this is an add function inside of an implementation. That way, if we want a function, we've already stored all the symbols in a dictionary or something. And we can just say, hey, what modules are there? Like how many Rust modules are in this LLVM module? Oh, there's these modules. Okay, which functions do they have in there? Okay, it has these functions. That might be a much better way to go about this. And I wouldn't have to write a mangler, only a demangler, which we've basically already done. Hello, how's it going? So what we're going to do... probably name this something other than a module. Since we will have modules inside of the module. We'll just call it a JIT lib or something like that for now. Yeah, we'll call it a library. And we'll have modules inside of the library. Have a disambiguator. So I'm not working on BraneEngine at the moment. Right now we're doing a little bit of a research project. You probably know that I was working on, well, I've seen you occasionally pop up in the streams. You know that I've been working on a custom scripting language. Right now I'm exploring the possibility of using Rust instead of that custom scripting language, just because that would immediately give me something much better and a lot more robust. So right now, so I figured out, and this is kind of like where the research part comes in, that I could use the exact same runtime that I'm using to run my current scripting language, and I could just throw stuff from the Rust compiler into it. So yeah, you can actually make Rust C, which is the Rust compiler, emit LLVM bytecode, and I think you could do that with CLang as well. So technically I could do this with C++ if I wanted to, but I'm like, let's just use Rust. Anyway, so we have it emit the LLVM bytecode, and then we get, you know, this bytecode file. C# compiles to JVM, and you would have to run that with like the mono runtime or whatever. And I just don't want to have to deal with garbage collection or anything. What Unity does is you can either run it in the mono runtime or some other JVM. And then I think, yeah, well, I know that you can also use LL something or other to CPP, one of their second build pipelines. Well, Unity will actually cross-compile the C# to C++ and then compile that. I don't know how that works, because obviously you're not doing memory management at all. So there's probably still a garbage collector in the background. It's just the code is no longer running in the JVM. Now technically, if I found a LLVM front end that compiled from C# into an LLVM bytecode, theoretically I'd be able to use that in here, but then it's, I don't know. I don't feel like it. Hello there. Today we are working on JIT compiling Rust, essentially. But not really, because we're not using like Rust as the input. We have an intermediate step. But that's basically what we're doing. It actually has been so far. I've just been doing this over the weekend in my free time. Name disambiguator. So we're gonna store the raw mangled symbol in all of these. Actually, let's just make this a struct for now. These are the two main parts we care about, though. Do we back reference the... No. So go module, and let's... And we'll have a list of functions here. JIT module. And JIT library. We'll just prefix that so we don't get them mixed up. So we'll store the unmingled symbol. Also store the argument types. And for now, JIT type is just going to be symbol and then yeah, we'll do an enum. But we're not going to use this. We're actually going to pop over to the mangler here. Actually, not even the mangler. So we have our namespace, and in here, oh, stop that. Basic type. Oh. Just gonna grab this enum. And we're just gonna add one extra for named type. Scope that. Go back over to Mangler. We're gonna just put Rust types here. Then back over here, got some big swaths of code. We're basically gonna have to say replace this with Rust types. And there we go. Back to library. So we have a JIT type, a JIT function. Then it is. It's very nice. Though sometimes it can be overeager and mess up your coding. Need a void type. Just trying to decide. Do we use no args for void? We'll just add a void to the end there and use it for return values. Or actually no, I'll put it up here at the top. make it the default. So now we have JIT type, return type there. Make that an optional so we don't always allocate a string. It might be a good idea to allocate all the symbols in a pool, and then we'd be able to get all the references to a symbol. You know what? Yeah, let's do it. Struct JIT symbol. Yeah, there's so much so much weird stuff in the new C++ standards that you almost never use because a lot of times it's just easier to implement your own type without the weirdness of the standard library. But I don't know, since I might eventually rewrite this entire project in Rust, I'm like, all right, we're using optional, we're coding in the spirit of Rust, but in C++. So how much metadata do we want to have here? Yeah, I spent the longest time not touching Rust because I knew the instant I did, you know, I'd be just completely taken in by it and just have to throw all my old C++ code away. So I'm like, okay, I'm not gonna touch it because I know if I touch it, I'm probably gonna love it. I touched it and I'm like, I just have to use Rust now. I'm still learning a fair bit about it, but it has been fun so far. So we'll just create one type. We'll have struct enum implementation function. That's all we need for now. And globals. Let's add a global variable into here. Where do you put the public? You put it here, I think. No. Can you do global variables? Or is Rust just smart and not let you do them? Okay, yeah, I'm seeing the lazy static being said there as well. Trying to figure out the non-macro way to do that. Okay, so this works. But heap allocation is not allowed directly. Okay, so lazy static is what you would do if you need heap allocation globals. Anyway, I just need to see what the symbol looks like. And just seeing if they're a possibility in general, because I'm like, I don't know, Rust might just not let you do globals. I haven't checked because I don't ever use globals. I mean, I use them on very rare occasions, but it's usually as part of an API, and I'm not going to be using the values directly. What was I doing? Right. We're defining this whole deal. So we have the text of the symbol itself. I think I actually want to use this type here. So I'm going to move all of this into the name of this is going to be Rust symbol. Have I done my thing yet? I have not done the thing yet. File naming camel. Move it to the top so it's default. Okay. It didn't do it. Just gonna delete that right away, and we're gonna go copy and paste all of this. here. I found it super interesting looking into how the ownership system works. And it's interesting because like I wrote this entire code base in a style inspired by what little of Rust that I've used, and I don't think I've actually gotten a runtime exception yet, which is kind of funny. Okay, we're still going through the print functions. All right. Invalid operands. Is OStream just not? Oh. I would do it. Okay, and what I would really like to do is have it so since we're going to allocate symbols from a pool, so there's only ever one instance of a symbol at a time in the entire system, within reason. What we're going to do is make it so we actually allocate symbols out of a pool. At least attempt to. What did I, oh, Rust symbol. We want to include Robin Hood. Oh, thanks for the follow. It is appreciated. So we're going to create a base struct for all of this. And we're basically going to make all of this inherit from Rust symbols, so we can store all of it in one place, in one map. So any of these that aren't inheriting from something else, question is, how do we efficiently check if a symbol already exists? So we'll have the raw version of a symbol here. We'll have the symbol AST. And what I'm going to do is, since we are coding this in the spirit of Rust, even though I absolutely hate using shared pointer, have these be weak pointers. So whenever we look up a symbol, we'll say, okay, does this symbol already exist? Or sometimes, has it existed? And if it does currently exist, we'll just create another strong reference to that and keep it alive. So that essentially pulls everything from this demangler, meaning we'll have to keep a reference to the mangler alive in the runtime, which is fine. Okay, match backref. We definitely know that this would always return a new symbol. I mean, not a new symbol, an old symbol. Joey, now I have to refactor all of this to include the raw version of it. See, what time is it? 10? Okay, I got more time. Sorry, just looking through work emails. I don't have anything urgent to go through. It's just like, oh, I have work emails. Nothing urgent at 10 p.m. at night. So, what did I actually open my phone to do? I feel like it was something. Oh, yeah. All right. back to it. Okay. Let's do it with the main things. No, we need to do just storing stuff first. Okay. Okay, Rust namespace, match namespace. Again, I'm going to make a couple helper functions for this. String. Hit range. CPG start. Let's see if it can do. Yep. Copilot can write that. And for now, we're just going to assume that it's a valid range. Because assumedly, we'd only ever run this function after range is complete. Okay, so back here, lifetime. Let's do lifetime first. Oh. I'll just go through return then. Go with raw text is get range start through telg. Yep, Yes. I don't think we're gonna go as far as having lifetimes be recycled. And for now, we're not worrying about it. Oh, I already defined one. Okay. Just, raw text is equal to get range. Okay, it's basically going to be a lot more of me doing this, and I want to start. Should probably be a good idea for me to start going to bed earlier, especially since I have early work stuff in the morning. Anyway, probably going to end the stream here. You will have noticed that I did take a large break from my last stream. It's just due to work stuff, and I'll probably be making a YouTube video on what's been going on and why stuff has been delayed. But yeah, until then, I'm gonna try doing like just smaller, more random streams. The days of 5-hour streams are probably gone for now. Maybe they'll come back sooner. We'll see. But yeah, until next time, I'll